Okay, so let's talk about some applications here for planning, estimating, pre-construction. Um, there are a bunch of applications out there already. We've kind of hit them at a high level here in the first module, and we'll go into a little detail here on some of these specifically. You look at planning. There's design tools and different LLM applications. For estimating, we'll talk about some long range programmatic estimating tools. Show you some examples of that. Same thing with cost indexing, construction cost indexing, which is, if anybody's been awake in the last couple of years, with costs, it's been a really wild ride, right? Mr. Toad's wild ride of sorts. So being able to quickly generate accurate or as accurate as you can get cost indexes is really useful. They'll also look at some pre-construction applications for like utility location, identification, deconfliction, right-of-way, and then also, if we got some time to talk about BIM, pre-construction to O&M. So this is something we're going to see more and more is automated or AI enhanced or supported design software. And you're going to see much more, a lot more applications that will just, like I said, they're going to show up in the software update if you're a designer, or you'll have an opportunity to buy a plugin, right, or something like that with your software, and it'll do things like automate some of your, some of the mundane tasks of drafting, right? Same thing with doing calculations, right? Running your calculations for you. Being able to do work with optimization. If we're looking at doing designing a pavement, right? And I can look at various alternatives. I can generate alternatives based upon the material type, how thick it is, what type of sub base or base course am I going to use, and we can go through and do some optimization so we get better designs or ones that are optimized towards our goals, right? And really, I think some of the benefit here, we're going to see the direct benefit of this automation is that it's gonna let us be able to spend more time focused on the decisions. Because really, as an engineer, I mean, engineers at our core are professional problem solvers, right? We solve problems. We like puzzles. We like fixing things. We like figuring out why things don't work. Figuring out how to create some novel solution or solution to a problem. And in design, it's really, the mundane stuff. Like that's why, if you've been around for a while, back in the day when we just had draftsmen, and that was an entire like profession, was to just be a draftsman. Got their big drafting table, pencils and pens and stuff, and run the mimeograph machines, back when blueprints was literally because they were blue, right? Because that was how you copied them. They were on a blue paper to copy over. And in the same way that we used to use separate employees for drafting, we can automate some of that drafting, right? Instead of having to use my engineers as CAD jockeys, I can use my engineers to be engineers, to make decisions, to go, okay, let me look at what we put together and make adjustments to how we're going to approach this design, right? Does this accomplish what we need it to accomplish? And I can spend more time doing QA and QC on my design documents as well, because everybody knows that. Well, I mean, not everybody knows, but one of the top two causes of construction claims are problems with plans or unforeseen site conditions, right? Unforeseen conditions. So if I can improve plan quality so that I don't have as many errors, then it's more constructible, that it works better, that there's less ambiguity in it. That's better for everyone, right? Better for me, better for the DOT, better for the contractor. So being able to let us focus on things that add more value, and really, I think this is also where you hear people really kind of hyperventilate over, we're going to lose our jobs. AI took my job, man. No, we're gonna see transition, right, and retraining, and people who are doing things that that could be replaced with automation are going to be shifting over to doing other things that don't require automation, that need a human in the loop. A great example of this is when we first started seeing ATMs roll out back in the late 70s, early 80s, something like that. We started seeing ATMs out. People were hyperventilating over what is going to happen to bank tellers. Bank tellers going to lose their job, man. They're going to take your job. ATM going to take it away. I go down to the bank right now. Guess what? There's tellers behind the counter. Why? Because they didn't need to just hand cash out. I got a machine that can count my cash for me. Teller does something else now. Tellers do other things, right? They've had other responsibilities they're able to take up. They do other things that add value at the bank. And it's the same thing we're going to see here in engineering and construction, is we're going to see some shifting in the kind of work that we have to do. And there's going to be people who are gonna be able to make the change. They'll see the value in doing other stuff. There's other folks who are going to leave the industry because of it, right? But for the most part, I think what we're going to see is we're not going to see this like massive die-off of the need for professionals. We need professionals. You've got to have somebody in the loop, right? Just like the lawyers earlier this year who really stepped on it by using ChatGPT to write up their legal case. You got to have an engineer to be able to stamp the plans. It's a legal requirement, right? We need to have engineers and we need to have professionals to be able to look at these things and make sure they're right to make those decisions. So that's kind of what I see a lot of the benefit here is that it's going to give us more time to be able to focus on things that would otherwise we would have less time to focus on, right? That are more important. And if we can automate some of these tasks, that really helps out. Same thing with generating design alternatives, right? So if I've got an automated drafting system, right, and it knows how to lay out whatever the facility is I'm trying to lay out, I can also have it give me different options, right? That's part of any of these deep learning models or machine learning models. They're iterative, right? They use statistics, probability, and iterations. They iterate, and then they develop their knowledge based off of the analysis of each iteration, right? So if you look at some of these simulation models you're running, it's 1,000 iterations, 10,000 iterations you're going to run on a simulation model. That means, guess what? Those are all unique iterations or fairly unique iterations. They're not copying the same thing, but they're similar, right? And so to be able to do things like generate design alternatives, like, oh, hey, guess what? You could also do it this way. We moved here 1 foot to the right, it would change this, or 1 foot to the left, or, if we added an inch or took an inch off, right? And we can look at those alternatives. We can also use it to put those things in and say, hey, what if I use this? What if I, instead of using RCP, I used polyethylene? What would that do? What would it change anything? What if I instead of using a triple box culvert, I used a precast concrete arch bridge structure here, right? What's that look like? What's that change for my cut and fill? What about my labor, right? And we can pretty rapidly do some of these analyses and be able to evaluate them and make the decision, because it's the people who have to make decisions. So this also lets us be able to integrate data across multiple domains. So where we have some of these, especially like the bigger software developers, like these images come from Bentley. So OpenSite Designer, and then Plaxis, the one down here is Plaxis. That's their geotech design. This one's OpenSite, and it's for doing site development, roads, bridges, that kind of stuff. And what we're going to see is where these larger, well-funded software suites are literally a suite of programs that are going to be able to access all sorts of different kinds of information, and we're going to be able to reach across and do a lot more things with just one or two programs than we had to use before. It's just the same way that, I'm carry a cell phone in my pocket. Back when I was a kid, I would have to have I'd have to have a camera. I'd have to have a VHS recorder. I'd have to have a hand calculator, right? I'd have to have any number of things that are replaced by just this one device. It's the similar sort of thing that's occurring here, where we're able to reduce the amount of touch points for us to be able to do things So that gives us really more time. So, and these are all ones that are currently being used right now, right? And there's also specialized applications for ones like, doing geotechnical analysis, bridge design. That's a great one. Hydraulics, hydrology, you know, tunnel design, like optimization, surveying, you name it. So I'll show you an example here from automated bridge design that they've got. And this is one of their from Bentley. It's their open bridge designer. And what's interesting about this one is, this setup lets you be able to develop your bridge model using libraries. And this is libraries of components with embedded information in them, right? So I figure out what kind of bridge it is, how many spans I think I need, the type of material, right? And then I can go in there and I can pull these out and I can draft this model. I'm going to make this model, right? And I'll be able to put this model down over, integrate it with my topographical data, right? So I can make the model, I can put it on my topo plan, and it will automate some of the alignment, right? It'll help me with getting the alignments right, getting all my angles and approaches and whatnot correct. And then I can take and export that and convert that physical model that I've drafted in here into an analytical model. I pull that out into the analytical model, and now I've got the opportunity to go and say, okay, here's my analytical model, and I can run all my structural calculations, right? And like with this one, they've got plugins essentially to be able to export it to an analytical model, and then I can go and use the latest AASHTO codes to go through and verify that everything works, right? And if I find something doesn't work, it'll show me, and I can make adjustments. Like, oh, looks like I need the next size up. Hey, maybe instead of using precast, we're going to use a box curve, or whatever it is, and we can make those adjustments. And then within those adjustments that you modify in the analytical model, get converted back into your physical model again, and it automatically updates it, right? You don't have to go back in and redraw things and make changes to it, because it automates that loop. So what you have is these iterative kinds of loops, and we're talking about, how do you work through some of this? And really from a coding standpoint, loops are really you see a lot of loops in the code on things, right? It's going back over and looking at things in these various loops, right? What we're doing here is we're being able to benefit from that. So like if I take my model, I convert it to analytical model, I make some changes, it goes back into my physical model. Now I can update that automatically, and I can generate things like reports. I can automatically generate schedules. I can put together, here's my rebar schedule, right? Here's my, here's all my my columns. Here's my schedule for my columns. Here's my schedule for my roadway. And it'll automate those things. It'll pull them out, and it saves a lot of time. And it also improves the level of your ability to be able to produce really high quality designs, and your confidence in it, right? So if I know that this is linked up to AASHTO, the AASHTO codes, I know that this is going to comply with AASHTO if I do it right and it doesn't throw any red flags, right? And that's the way it is. I'm going to go and I'm going to validate it. I'm going to check it, right? I'm going to make sure that it is correct. But it really increases my confidence level, a level of confidence. And then also, if you look at some other kind of applications where maybe you got code changes, right? Hey, we did this, we're using the 2009, ODOT 2009 versus the 2019, right? Being able to reference those, right? And say, and to be able to automatically understand that, hey, this complies with this code, this complies with that code. So this is kind of a cool deal. If you haven't, if you're looking at any of this stuff, there's a lot of the tutorials and stuff, marketing materials out there. They're real interesting. If you're looking at kind of how some of these things function, how these things work. So, but this is just one here. So any questions on that? Anybody used one of these before? These kind of programs, I guess. No.
I use the Open Bridge Designer.
So then you're familiar with how this works then, huh?
A little bit, yeah.
Yeah. Yeah, and that's the other thing too at training, which is really I really appreciate, is a lot of these, the software companies are really good about making training very accessible. So typically short videos, You can get on, you can learn, you know, if I'm working through something and I'm trying to figure out how to get some piece of software to work, and before I spend a lot of time trying to figure it out myself, I'll just go to their website and try to see if they've got like a training FAQ or library or university thing like that, and go see if somebody's done it. Or I'll go to YouTube, or I'll go onto Reddit or somewhere like that where there's maybe a community that, you know, folks are like, you know, talk about how they're using those specific kinds of software. So you can really get up to speed fast and get pretty dangerous with without having to spend a ton of time and effort, you know. All right, so oh, I lost. There we go. All right, tracked across. So LLM applications. Now, you may not have realized this, but if you've used a search engine, you've already been using LLMs, benefiting from it. Google, Bing have been using LLMs in their search engines here for a while now, and it's pretty interesting too, because it works to really increase the relevance of your search results, and it's replacing a lot of these older kind of dated methods like PageRank, you know, or keyword algorithms, where it's just looking for keywords or number of keywords, you know, and where people have learned how to spoof the search engines. I don't know if you know, back in the early 2000s, and you'd get on a website and there would be all this white text on the bottom you wouldn't see. It was like all the keywords that they'd put in there so that it would get picked up on the site, you know. But the text was in white and the background was white, so you wouldn't see it. But if you highlighted it, boom, you'd see all that there on the bottom, you know, this like word salad garbage, you know. So some of these LLMs have done is they've replaced some of these with they've or supplemented them, right, with additional techniques of being able to identify what's really relevant. There's also proprietary LLMs out there that you can use for doing searching internal documents, you know, reviewing contracts, going through records and that kind of stuff. There's ones where you know, there's some proprietary LLM providers out there who will set up enterprise applications for your company, you know, or for your firm or your organization, where you can use these like, you know, kind of customized internal search engines that will then query your like shared drive and anything that's on, you know, your servers or on your desktop, be able to pull data from various different places and aggregate it for you. You know, I mean, like it's like I even just using like your search function in like Windows when you open up File Explorer, you know, see applications like that that'll continue to improve. It's like, where did I put this on my where did I save that file? You know, go and play and hunt and peck. You know, reduce the amount of time it takes for those things. Generative writing and editing applications are probably some of the ones that people are most familiar with, as they see a lot, right? But when you look at it from a professional side of the house, you know, or a point of view, there's a lot of opportunity to be able to assist with business communication, professional communication, right? Being able to build, you know, put together, you know, like templates, cover letters, business letters, automating some emails, right? Being able to generate reports, help with assisting with writing reports. So if you're a geotech engineer, you know, you're always generating a lot of text, right? Anytime you do an investigation, you know, you read those geotech reports are like this thick, you know, they got all sorts of words and stuff in there. And, you know, oftentimes what we see is, you know, and everybody does it, you know, so no, don't, you know, no shame to anyone here, but, you know, if I've already done it before, I'm not going to do it again. Right. So I'm going to reuse text I have and reuse different clauses maybe I've written in there. I'll reuse details, plans, that kind of stuff, right? This is the sort of thing that can help with that and be able to, instead of just reusing it, to be able to bring it in and adjust those to work for that specific thing that you're doing. So, and reduce the amount of time I got to spend going through and doing that. Writing and editing proposals, general contractors, you know, if you look at the cost and the time that it takes to put proposals in, and even as an engineering firm, right? Your GEC, you know, you're going after pursuits. you know, every different owner wants, they want your resumes, they want a specific form with your qualifications and your experience. You know, you'll have like, hey, there's a 10-page limit, you know, show us the projects that you have that are highly similar to the one you're competing for here, right? And it can take a lot of time to generate that stuff. So this is the kind of stuff you can help, you know, generative text LLMs can help with being able to take and prepare the baseline for that, like the backbone, you know, the skeleton, you know. So like if I go in and I say, okay, here's my, you know, I dump the proposal, the RFP into my LLM. Say, okay, which of my projects that I have are the most similar to this one, right? And then go, here we go. Here's prioritized. Okay, summarize each of these projects, how they're similar to this project, right? And it'll give you some more text. And then you just got to go through and edit it, right? You can also use it to do editing. Hey, I need this to be more succinct. Edit this so that the writing is more direct, right? And it'll go through and it'll make you know, trim things up a little bit. You got to go through and read it, make sure that it hasn't deleted something or added something goofy in there for you. You still got to go in and do it, but it takes a lot of that. It can take a lot of that time out. Specs is another one too. Let's see, why is that? There we go. Okay, I want to take that off. Spec writing can take a lot of time, right? And especially if you're writing anything that's new, right? You're not just reusing specs, or if you're doing alternative delivery, right? Where you're gonna be writing performance specifications or performance criteria, and we're not being prescriptive, right? You know, I'm working with a client right now where we're taking a prescriptive design and converting it into an RFP for a design build project, right? And which means we're only gonna be prescriptive on the things they absolutely have, and everything that's not, I'm gonna use performance language for. I'm gonna specify performance. You know, I don't care what the structure is as long as it's sufficient, right? I'm not going to tell them it has to be tilt up concrete or it has to be structural steel. I'm going to say I want the structure to be fully enclosed and insulated and right? And describe how it performs. LLMs can help you with being able to convert prescriptive specs into performance specs or into performance criteria, and they can learn how to do that. So I can put in there and say, hey, referring to the Design Build Institute of America's best practices for, you know, performance specs, rewrite this specification as a performance spec, right? And the LLM is going to go and it's going to learn what that means at DBIA, and it's going to come back and it's going to rewrite it for me, and it's going to take like, you know, a minute for that to do. And then I just got to go back through. I can reiterate it, say, oh, try again, right? Oh, this is better. That's not better. And then I can just take and export it and make sure that I edited it up, and that saves a lot of time. You know, I can save a lot of time. And can also help with improving the quality of some of those too, because it'll identify things that you may have missed, right? You may not have thought that need to go in there. So this is another one. Code compliance is another opportunity there too, right? Doing code research. Hey, what codes apply to this? You know, hey, I've got to do I think I need to do a storm shelter. I'm not sure if I need to or not. Which codes do I have to follow? What's the criteria for that, right? And it can summarize criteria and pull from any kind of open source document like that. So those are some applications. I'll show you one here on the next slide in that. Another one is that extraction, right? So being able to extract information from documents or collections of unstructured data, and to be able to use that and convert that into meaningful information. So my example here for, you know, if you're a engineer and you're competing on RFP, right? I can dump an RFP into an LLM and say, hey, tell me what are the top 5 most important aspects of this RFP to the owner, right? What do I need to win, essentially, right? I can have it analyze it, say, what are the things that, you know, that will, that I'm not supposed to do according to this RFP? What are the qualifications that I have to have? Give me a list, right? What do I have to have for, personnel as far as qualifications and da 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 da. Give me a summarization or a bulleted list of it, and it'll spit that out for you. It'll go boop 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 boop, and now I've got something I can work off of, as opposed to having to go back through there myself and spend all that time to extract that manually and identify what those are. Right? I'm still going to read through it. I'm still going to read my RFP. Right? But I'm going to use this as a tool. It's going to support me going through that. So I'll do that first. Then I'm going to go read through my RFP with what I've generated alongside there and say, okay, oh yeah, here we go. That's where that is. That's where this is, highlight it, reference it, make sure that when I'm putting my proposal together, I got a checklist now that I can knock off and say, okay, boom, 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 boom. These are the things I have to have. Here we go, and proposal preparation is a pain. It's an absolute pain. I love winning jobs. I hate having to go after them. So if you have little things like that you can do that can help with ease some of that pain, it'll help you write better proposals, and do a better job of being able to describe, your qualifications and be more competitive. So another application here is for data extraction, comes from daily work reports, and I'll show you one here at the end of the day that's an algorithm that extracts data out of daily work reports. But if you ever get into a claim, right, God forbid none of you will ever have another claim again. I know that's not true, right? There's one thing that you can guarantee is that things will change and we will have claims, right? But if you get into a claim, being able to go in and do that kind of front end due diligence and figure out, okay, hey, is this merit? Does this have merit or not, right? Is what I'm being told factual or not, right? Is there other contextual information that I'm missing, right? And being able to automate some of this stuff to generatively can be really helpful. So I'm doing DOT work, I've got daily work reports I got to put in, or my contractor does. I've got inspections, right? Site visit reports. I've got all this data that's generated there. Same thing with invoices, pay applications, right? Here's how many yards of this that we did this month, right? Those sorts of things. I can go and extract that data to look at it and say, okay, hey, did we actually have a delay here or not? Do we actually have a claim? Was there any change? Was there not? How much actually was here? Wasn't here. I had a claim that we did with a client several years back. They had a delay claim, looking at they had it was a design build project, 6-month delay. They wanted $500,000 because they said the county had delayed them because they had held up their permit. Right? They told them they had to do didn't have to do a slope stability analysis for this one feature, and then they came back and said, well, no, you have to do that, right? We'll give you it without it. No, you're gonna have to do that first to get it. And then they said, okay, so yeah, we got the 6-month claim. Da 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 da. Well, we looked at the schedule, and turns out the schedule didn't have a critical path, right? They had hand inputted one of the numbers wrong, one of the start or finish dates in there. So after like 2 months, the critical path died, it disappeared, and it showed up at the end, right? But being able to use this to rebuild, right, that schedule and do those extracts, we're able to come back to our client and say, hey, guess what? They don't have a claim because there's no critical path, and if there's no critical path, there's no impact critical path, right? And they're like, there's no critical path. And I'm like, yep. Wow. So, they're able to negotiate that one and get it back going. I mean, it ended up being, they gave them a month, and I think it was $150,000. But you're able to find that kind of stuff. The other thing we found was they were trying to get well. It was a design build project, and if you just looked at, hey, what are the activities on the first schedule? What are the activities on schedule update 64? What's the difference, right? Oh, hey, by the way, there's 130% more activities on this one than there was on the first one. Well, guess what? That's because they left them out up front, and now they're trying to roll these into the claim, right? To make it so they can get that covered, right? So those are the kind of things that can give you negotiating support. So when I go in and I talk, I say, hey, well, we understand you got delayed, but I don't think it's this much. Here's why, And if we can negotiate these things, and instead of having to go through arbitration or go to court or that sort of thing, everybody benefits from that. Like nobody benefits from having to arbitrate or litigate except for the lawyers. They're the only folks who benefit from that. So these are the kind of things that we can do using, LLMs, using some simple, these kind of tools in various different kinds of ways. So I'll show you here. This was one I did. I was putting this together. I thought, okay, well, let's look at what we got. All right. So I said, using ChatGPT, I put this prompt in that said, list the applicable building codes related to construction of water treatment plants in the United States. Pretty simple thing, but there's a lot of codes out there, so who knows what they are. And this is what it gave me. So, and I'll just kind of zoom in real quick so you can sort of see the first one, right? So it kind of gave me this little deal about, hey, guess what? There's other stuff there too. So these are probably relevant, right? So IBC, IPC, NEC. Oh, here we go. AWWA, American Water Works Association. And then guess what? They summarized it a little bit for me, right? So, and over here I had, looks like NFPA, EPA, and then it talked about some other ones as well. But you can do this kind of stuff where it gives you a nice little list to start with, right? And even if it doesn't tell me specifically, like I could go in and if I refine this search, I could go in and say, okay, what are the applicable sections of the AWWA standards when it comes to water cleanliness and quality, right? And then it should be able to pull those out and tell me what those are, right? Give me a reference, maybe extract the actual code itself, right? And be able to use this as kind of like a research assistant, essentially, right? So if I'm doing, and also if I'm an owner on the owner side and I have to do code review, code official, this really helps out a lot too, right? Because I can use this to be able to go through and make sure that, hey, are there any other ones that weren't considered in here? Hey, are these the proper ones? And be able to automate some of the stuff again. So I'll show you another one here. This next one, I wanted it to write a performance specification. So I just figured, okay, what's a simple one? Probably traffic striping, right? So I said, okay, write a performance specification for traffic striping that complies with the MUTCD. Right. Very focused direction, and this is what it created for me. And I'll zoom in here so you can kind of see this a little bit, but so it actually wrote this out. Okay, here's my purpose, right? Here's my applicable standards, MUTCD. Here's my materials, right? Here's configuration. And you'll notice that this is all, there's no numbers or anything in here, right? This is all text, right? Which is what you're going to find with a performance specification, right? So it's converting these things, it's stripping out the prescriptive parts, and it's leaving the stuff that I need that I'm going to hand over to a design builder or somebody like that, and that's going to be responsible for making sure that they comply with the design, that they comply with that. So this is, and this probably isn't even a very good one because I only did one iteration on this. Yeah, if I went back and iterated it a couple more times and read a little bit, maybe I'd have something that's a little more succinct and well developed. But this is the kind of thing; these are the kind of things you can do, to be able to that was 2 pages roughly, a spec. If you had to write a 2-page spec, how long would that take you? 30 minutes, maybe hour, at least, more than likely. And if you're if you've got any OCD, or a perfectionist, more, right? Well, let me make sure this is the right one here. I got to double check, triple check, right? So this is the kind of stuff that's really readily accessible. I don't need to pay anything for this either, right? If you have like OpenAI, their ChatGPT thing, you get a certain number of prompts you can write. It's like per hour. It's like 20 an hour or something like that. Every 3 hours, it's more than enough. If you want to do like the personal plan, I think it's like $20. Hey, just so everyone's on here, I'm not getting a kickback from OpenAI for talking about this, but anyways, this stuff it's accessible, right? And then also I think with 365, Office 365, they've got Copilot in there as well. So there's going to be opportunities, I think, to use those. I think you can use Bing too. Bing's got maybe one. I haven't used them before, but this is the kind of stuff that's real easy out there. And really, what all this takes is for you to think. If somebody told me what they wanted me to design, how would they tell me, right? Or if I told one of my employees, a junior engineer, what I wanted them to write or make, how would I describe it to them so I knew that they understood and did what I want them to do? And that's really all you have to do to use a LLM for write text prompts. Now, they actually, there's another interesting thing is there's some new job titles that we're seeing, some new job descriptions coming out, and one of them is prompt writers, people who specialize in writing standard text prompts for LLM models that can be used at the enterprise level, right? So if I put together a really good combination of, if I got a really good like text prompt that gives me something that's really nice, I want to hold on to that, right? I want to save that text prompt, especially if I'm going to use that again, because then I don't have to think it up again. I can have that to plot back in. I can make some tweaks and adjustments. There we go, right? So it's real interesting to see kind of some of these changes. So there's, maybe that'll be a good job for some of the folks who are running around as baristas, with college degrees. Maybe they can write text prompts instead. But those are just two applications. And again, it's really kind of up to you to figure out what you want to do, and you need to play around with it. It's experiential. Frankly, it's fun. So, okay. Any questions on the LLMs? All right. And I know there's probably some of y'all over there online who are dinking around on ChatGPT right now, trying some things out. So let me know if you get anything good that turns out. You can share those text prompts with us here in the chat, and maybe I can put that in my notebook. So, all right. So let's look at some estimating applications. So, programmatic estimating tools can really help with being able to have an early confidence in the cost of my project. So, if anybody's dealt with the STIP or master planning, putting together these master plans for projects that are like 8 years, 10 years, 20 years out, right? FHW, I think I got their long range ones like 22, 25 years, something like that. Way the heck out there, right? And if you're working for a DOT or a transit authority or toll authority, you've got a lot of infrastructure to manage. You're looking at, okay, what's the lifespan on this? When do I have to go back here and resurface it? When do I have to go and do repairs? When do I have to replace it? Right? How much are these things going to cost? And there's lots of competition all the time for these big projects because you got a lot of political interests. You've got all sorts of other things going on as well. So really the challenge is, in spite of all of these pressures that I have, I need to do a good job of identifying how much money I think I'm going to actually need, right? Because at the end of the day, when I get down to when this thing gets on the master plan, it's going to be on there for a while. And when it comes down to the point where it gets funded, it's going to get funded. I'm going to go procure it, and I got to go build it. But what I want to happen is, when that last pay app clears for my GC, right, that I didn't have to go back to the well, right? Or if I did have to go back to the well, it didn't kill the project, right? So that long range goal for being able to program funding is I want sufficient funding. I need to have sufficient funding in place to cover those way down the road, right? Now, at that point in time, I'm dealing with very, very basic requirements, right? A narrative scope. Maybe it's not even a sentence, right? I've seen some of these where it's just a phrase, resurface 10 miles or 8 miles or whatever the magic number is here in Oklahoma. At this stretch of highway, do repairs, do this or that, replace the bridge. And one of the things is we always have we have more projects out there than we can pay for each year. We got more projects than we can get approved to go on that master plan or the STIP each year, right? So we got to figure out which ones are going to be prioritized. We also have staff challenges, right? If you're working for a public agency, staffing is a big challenge. I mean, even private private folks, yeah, staffing is a challenge. But you know, a lot of the DOTs are really struggling right now with having enough people on staff to do the work. So you've got folks that are focused on managing actual projects that are going on right now, right? And they have other stuff going on as well. So really, you don't want to have you need to have the people who are involved in this to be able to do it without having to take a lot of staff effort to develop these up. So this is one of those things that you can get with a programmatic estimating tool. So the one I'll show you here is a top-down parametric estimating tool that uses a case-based reasoning machine learning algorithm to select highly similar historical projects, and then use those to run through a Monte Carlo simulation to generate a credible range of cost with statistical confidence intervals. And kind of the way this works is you have these base characteristics of the project, right? Here's these few characteristics that I've got. And what my CBR does, case-based reasoning, is it distills all of my historical costs or historical projects into individual cases. And then it figures out which ones are the most similar to my one I'm trying to estimate. And then it only pulls those ones out and uses those for simulation, right? Because the challenge is with statistics is we want to achieve normality whenever possible with our data. And one of the challenges in construction data is, if you listen to Professor Sweatervest, who's down at the university teaching statistics, they're going to tell you you don't have enough data points, right? Oh, there's not enough projects. You didn't even hit n equals 32, right? N equals 30. It can't be significant if you don't have that many, right? I may only have like 3 projects in my database that are similar enough, right? So, but one of the things that we've shown is that, when it comes to normality is not just the number of total projects. It has to do with similarity of those projects, right? And that's really the underlying drive is what can I find that is more like the project I'm trying to do to use as predictors. So pulls out ones that are highly similar. We normalize the historical costs for geographical location, as well as moving those dollar costs up into year of expenditure, right? Either midpoint of construction or whatever point that happens to be, right? We want to escalate those. We're going to index them up. Geographical location is huge change in where things are located and the cost of that. So this one was, we first developed this for Caltrans back in around 2010 with David Jong and our partner down in Texas A&M. Help them improve performance of their annual program, which is about $14 billion. So pretty big one. And they were looking at trying to improve, the contingency management and their overall expenditures by trying to figure out what do we actually need to have on here. So, and this one, we actually, the end result, they ended up being able to reduce the overall or improve it by 1%, right? So they spent 1% less using these tools, and at $14 billion, you can imagine how many like county roads and bridges that is. And that's really what it translates into, right? Efficient contingency management for a DOT means I get to do more projects. I can do more projects in a fiscal year if I have more money there to do it. So this was first developed for them, and then we ended up further developing this for the U.S. Fish and Wildlife Service. We adapted it to them in 2020, 2021. They got a bunch of money from the Great American Outdoors Act, and their challenge was they had 8 little regional construction service centers that are responsible for the entire United States and all their outlying territories. And there's like 8 people in each of these construction centers, service centers. So very, very small staff to support all of the fish and wildlife, refuges, wildlife management areas, fisheries, hatcheries, you name it. And to be able to take those requirements from the people who run those facilities are biologists. They're scientists. They're not engineers. They're not builders. And say, oh, we know we need a new roof, right? What do I need for a new roof? How much is it going to cost? Or hey, we need to replace the bunkhouses out here. Or hey, I need to overhaul this, my hatchery, because a hatchery is just a big water treatment center with very, very stringent standards for water quality. So we helped them with developing this tool as the front end, essentially. to take, okay, here's my requirement. What do I think it's going to cost so I can get the money programmed, right? And then be able, yes.
I have a question back one frame when you were discussing the estimating, programming,
Mhm.
artificial intelligence for our department. How would a person access such a program? Is this like a package the department would have to purchase? I mean,
Yeah, I mean, unless you
How does that
develop,
work?
unless you developed it yourself, yeah, you probably need to hire someone to do it for you. And that's something that we've done. So this is an example of one we've done. Like, so Caltrans hired us with to help them to provide consulting services, essentially to develop the tool.
would you know
So.
at first blush whether Oklahoma Department of Transportation has started conversations in that regard, or?
I couldn't tell you. No, I couldn't tell you. Yeah. But yeah, no, I mean, this is, so, I mean, that's kind of, a lot of these, if you identify a need like this, I guarantee you there's probably a consultant out there or somebody who's an expert who can develop these things, you know, and either collaboratively or hire them or whatever it takes. Right. But this is the kind of stuff that's out there. And actually that's a link to a paper I published we got this published this summer on the model that we used for this. So if you're interested in looking at what that is, it's on there. It's through the American Association for the Advancement of Cost Engineers, so AACE International. But this is kind of the process of it's a very simple tool actually. It's actually not complex at all. But it uses case-based reasoning, which is actually pretty straightforward algorithm. We actually wrote it in Excel macros. But there's probably a more efficient way to do it now. But the process essentially is you start with an estimate, right? We start with a requirement. Here's what we think we need, and we look at the characteristics of it, right? And you put in whatever those are in your little input page, and then what it does is it's going to look at, okay, here's my past projects, and I'm going to give it some guidance on either what I want it to pull from or not pull from. All right, so there's some, hey, this is a housing project, so don't pull anything that's a road, right? Only look at housing or this is a building project, so choose any of the building projects. Or hey, this is roads and trails, so I don't want to see any building projects. Or I think this is small, so choose small projects. Or hey, this is remote in a remote area, so only choose remote projects. So those kinds of things, and then it goes to the database. The CBR algorithm queries the database, pulls out a data set of highly similar projects that are rank ordered in similarity, with the most similar being at the top. And then it takes and it indexes all the data for location and price, brings it up into the location of the project, indexes it into the year of expenditure, and then you're able to run that simulation algorithm, the Monte Carlo simulation, generate your probability density functions, and that give you a range of likely values. So like this one here, you can see, so from 50% to 99%, right? If you ever dealt with like the FHWA, they like P70, right? Which is 70% confidence. And it just tells you, okay, here's with 50% confidence, this should be $2.3 million. If I want more confidence, it's going to be more than that, right? And really the way you interpret these is this 50% is the mean value, right? This is the average. And then whatever my above the money, however much it costs beyond that, above that, is my contingency, right? So if I'm afraid that it's going to cost more, maybe I choose my P80, and now I got 2.7 or $2.8 million in there, which 500,000 then is contingency essentially, right? So, and what that does is it lets you be able to have some confidence and accelerate the whole process. So this is kind of how it works, this tool. So we had a database. One of the first things you had to do is you got to figure out what matters, right? So we did some analysis on features that are predictive features, and this was from using some research that we had done previously, as well as some other research on the matter. Came up with some characteristics to be able to characterize our data. And then what we did is we went through and set up a pairwise comparison of them. And essentially, the pairwise comparison is a matrix where we're using some professional judgment to set ground rules for our case-based reasoning algorithm. Now, if I used a deep learning algorithm on here, I could have the deep learning algorithm tell me what those are, right? And actually generate whatever those that is from with statistics as opposed to professional judgment. But professional judgment gets you there without having to do that. And so all we did was you just go through and you rank, comparing them, that whatever that factor is compared to the other 5 factors. Hey, relative importance. Is it slightly more influential, moderately, strongly, whatever, up to 5 down to -5. And then we just have those rankings in there. And what it does is it calculates a percentage, an importance index, essentially. And which tells the CBR, okay, when I'm looking at importance, I'm going to go with whatever the most important features are first, right? I'm going to prioritize these, and then I'm going to go through, and it's going to convert each project into a case that it then scores according to its similarity to your target project, right? And then that's what it uses then to query and pull that out. So it pulls that out and gives you a list there. So the next piece here is, so you got that list, right? Asset type or project rank. And then it takes and normalizes the cost data, right? So it converts the total cost into a unit cost that's based on your estimate units, right? So my database has, whatever those primary or cardinal, quantities were. So if it's a road, like how many miles or lane miles or feet, right? If it's a building, maybe square feet, you name it, right? Into a single parametric that describes the value or cost of that feature. And then we index them. And what it does is then gives you a list. And at this point, you can go back, I could go back in there and I could manually add or remove them, right? If I see one, it's like, oh, why did it pull this out? I want to delete that. I go and remove that, right? And make any adjustments I need to. And then once I'm happy with my selection of sample projects in my data, I just hit the button to start the Monte Carlo simulation. It runs 1,000 iterations. So essentially it says, okay, for this kind of project, here's, it uses different distributions based upon the cost and the features and all that kind of stuff from each of those historical projects. It says, okay, it could cost between this much and this much, and it develops, plots out that probability density function and a cumulative density function, and it calculates your total cost with a confidence interval. So it gives you this stuff right here. So I get this, credible range of values with the associated confidence level. And then this is my probability density function, and this is my cumulative density function. The CDF is where it pulls for these levels here. Now, one of the easy checks when I'm looking at this is I've got a visual check, and I can look at this and say, okay, how confident am I that this is actually a pretty good result? And if I'm just looking at the shape of my density function, I'm gonna prefer ones that are more normal, right? Where it's uniform. It's a uniform bell curve, right? I want less skewness. The more skewed either way that density function is, the less confidence I will have in it being predictive, right? So, and there's different ways to quantify the level of skewness. Very, very easy, determination. If it's, between -0.5 and +0.5, it's essentially uniform. That's symmetrical data, which means that's normal. Even if I only have like 4 or 5 data points in there to build that from, I have a lot of confidence in that because of the similarity, and it's very normal. It means that all the data points in here are like the data points that I should expect, right? If I'm above 0.5 to 1, or from -0.5 to -1, it's a little skewed. Maybe I've got a little lower confidence, which means I'm probably going to choose a higher number over here, right? A higher confidence level for my estimate, right? If I'm have less confidence in that being predictive. So it's pretty quick. It's actually pretty good deal. And one of the things we did was be able to validate it. We validated it with actual historical projects, using that, putting those in just those characteristics, and then run the simulations, and all of them came within ±1 standard deviation of the mean values of the actual costs at either completion or at procurement. So, you know, if you can improve the accuracy, have really good accurate estimates before you even do any design, this really helps set you up for success, because you're able to know that I've got the money I need here for this, right? It should be this much, right? I should be able to be able to do this project for this much money, you know, because the toughest thing as a, you know, when you're working for any kind of public owner, or really any owner or whatever, is having to go back to the well and say, can we have more money? Oh, hey, by the way, we're over 10% over our procurement. It's going to be 15% higher. Can we get more money, right? And having to come back to the well, hat in hand, and beg again, right? Because that can be politically untenable or unfeasible sometimes, right? So that's kind of the point here with this. So top-down parametric tool just uses your real historical data to predict what it should be like if I use this. Just make some adjustments, and of course, you know, this is a basic tool, and you know, yeah, it could definitely, there's definitely opportunities to be able to improve it by doing things like, you know, pairwise comparison is probably the biggest one. Same thing with asset granularity. That's another big one too. So asset types. So in this one, you can see we had to combine assets. We just didn't have enough projects in the database, but as you build your database out, you can have more granularity, right? Break them out and you find those things that matter. So questions? All right, so this is one example here. Show you another example here on cost indexing, construction cost indexing. So, you know, construction costs are primarily commodity driven, you know, so that's why we have all these indexes that track things like the price of Portland cement or rebar, you know, like you talk to the folks down at the AOGC and they'll tell you exactly how much a barrel of oil costs, how much a barrel of asphalt costs, right? Because those things drive the cost of the work, right? It's commodity driven. Another thing we have to remember is that markets are highly regionalized. You know, where you do the work can be very different when it comes to cost performance, right? When it comes to how much things actually cost. And they can also vary substantially by market segment. You know, it's like looking at comparing roads and bridges versus utility work or versus residential construction. You know, those two are completely different. You know, very, very different ones. You know, like my example here for the region is, you know, anybody in Texas who knows where Muleshoe is, you know, working in Muleshoe, Texas versus Dallas-Fort Worth area. You know, there may only be one or two contractors out there in Muleshoe that do the kind of work you want, right? There may not be a bunch of competition from suppliers, from contractors that you find in a big, heavily built up area. So the market value is different. So rural, remote, urban, suburban, they're all different. And the other piece, the other wrinkle that we throw on top of this, not only is it highly regionalized, but costs are dynamic. And unfortunately, we've been lucky enough to live in this period of time when they're very dynamic, and which means they change a lot, right? It can have real rapid change in pricing. So because market conditions change. I mean, like who'd have thought that, you know, some joker would get a boat stuck in the Suez Canal? Like who can predict when the longshoremen are going to go on strike at the Port of LA again, right? You know, that's the kind of stuff that you don't have control over, and it has these big knock-on effects. So those are things we got to consider. And when we're looking at cost indexing, right? You know, historically, those indexes have been, you know, they're big, they're heavy lift. You know, major undertaking. They're usually like a, you know, national effort, some big, government agency or a consultancy that's doing them. You know, you look at the amount of time it takes to gather all the data, process it, clean it, sort it, normalize it, right? Characterize everything, go through and get rid of the trash, make sure you only have the stuff that matters, make all those adjustments based upon what they are, right? And then also, if you look at a lot of these cost indexes too, they're very specific on where they apply. So like ENR is a good example. So Engineering News Records construction cost index is based on major cities, right? There's like what 11 or 12 or 24, something like that. And it's really good if you're working in a major city, right? It's a good cost index for that. And they only track materials. They track like 2 or 3 materials, like concrete, rebar, and like 1 or 2 other things, or labor. I think some kind of labor. But anyways, so it's very focused, it's limited, right? Bureau of Labor and Statistics, we got a government federal agency that does this for a living. And if you look at any of the cost index data that they have, a lot of it's very, it's very generalized, right? It's very generalized. So, those are things you got to consider. And the other thing we found out is that, since the pandemic hit and all the fallout, data expires so much faster. Cost data does. If I'm putting an estimate together and I'm trying to find data for that cost estimate, I want to get the most recent stuff ever. If it's a year old, it may not even be worth it for me to use, right? Unless I do a lot of adjustments to it. And I have to do a lot of normalizing and a lot of corrections, right? And even then, just because the market is so dynamic, it may not be as predictive. So it's some things we gotta, that were challenges that we face. Now, one of the things that's nice though is because we do have some machine learning algorithms that we can really reduce the effort that it takes to build a decent cost index, right? Without having to go through all of those extra steps and spend all the time and money and hours and effort to develop one. So this is one. I'll show you an example here where we can use certain different types of data sources and then generate synthetic data as well, wherever we have gaps, to be able to create an index that's focused specifically on whatever that kind of work is that we're doing. And that's the thing you got to remember with construction costs is you've got to adjust those things. You got to normalize it. It's got to focus, be highly similar to whatever you're working on, for you to have confidence in it being predictive. So this one was developed here this year. We did for Amtrak. They didn't have any reliable construction cost data in their data set. They had very, very, very little usable data. They also received like $22 billion like a year or two ago to be able to fund restoration of service throughout the Northeast Corridor. So a lot of money. They've overhauled, helping with overhauling their capital program, and being able to actually spin the work out and do it, and spend the money. Because the biggest challenge they had is that they didn't move fast enough to be able to spend the money in time, right? They couldn't program it and get the projects from concept to on the street quick enough to spend the money. So this is one of the things they're looking at. And the other thing too was having to being able to index those estimates out into the year of expenditure. They didn't really have any data. So one of the things we did is we used the RS means cost data, as a basis, essentially, to develop a cost index that we focused in on the applicable divisions that of the work they're going to do in those cities in that corridor, right? Because again, means is Gordian owns RS Means, and they're focused on major metropolitan areas as well. So again, that's another one where a lot of people use it. Means is good for ballparks, and getting you in there. So and using it for base data like this worked pretty well. So kind of process, went in and pulled median values for each of these subdivisions that fell underneath these 4 divisions here, and used those to calculate a division value, right, for each city in each year. So we had a site work and track structure, railroad building facility, communication signals, and then an electric traction. So we had four divisions of work, right? And then to set that up, we had 5 years of cost data that we were able to build a index value for each of these divisions at each city in that area, right? And then the index value for that city represented its relative cost for work in that city compared to RS Means 30 city national average for that year. So whatever the national average was, it was an index off of that national average. So started with a value of 1 or 100, right? And then indexing it up each year as those costs inflated. Now, to be able to put this together, right, we used random forest. It's an ensemble algorithm, and we use that to forecast index values for the upcoming 5 years past 2022. So 2023 to 2027, I think 2028, right? Based upon the index values that we generated from RS Means. So So as a way to be able to predict, we used it, trained it on the index values from those 5 years to then predict the next 5 years. Now, random forest, talked about this, a little bit before. This is it's an ensemble learning algorithm, combines bootstrap aggregation and feature randomness. This is just a fancy word for replacement. So what it does is it randomly samples, makes random observations, random samples, and it replaces some of those randomly with synthetic data, essentially. So kind of the process is it's a decision tree. It creates a large number of decision trees, and then goes through and prunes those decision trees and averages them to be able to predict values. So creates somewhere between 400 to 1,200 decision trees from its observations on the data set and random sampling. And really the whole point is it helps prevent overfitting. That's what the random sampling and replacement does. Overfitting is a problem with bootstrapping and some of these other predictive models, because you don't want it to be overly similar to the model, right, or to the data set, where it's literally just copying it, right? We want it to because what it'll do is it'll carry all those biases over as well. So we want to try to reduce the amount of bias that's carried over from that data set and to make it more representative. So that's kind of what the process does. So in this case, and then it'll average the value. It'll calculate the average value across all the trees to determine the relative importance of each variable and its predictive ability. So it just goes through, and each of these, depending on how many nodes there are, these are each a yes or no response, right? Yes, no, yes, no, yes, no. And if it's yes, it goes this way. If it's no, it goes that way. And what it does is it separates the data based upon these responses on decision trees into different buckets. Okay, it goes in this bucket, goes in this bucket. And this is just categorizing it. I'm just categorizing features. This feature is related to this one. This feature is related to this one, right? And then it develops a map essentially of that relationship, and to prevent overfitting, it averages what those responses are across all those trees. So so this was the data on here from 2017 to like 2022, 2023, and then forecast up through here, right, for the next however many years, based upon that algorithm. So, and then this is put in a real simple interface. This is kind of a pretty common thing. You look at like dashboards. Dashboards are popular these days. We'll talk about some of those this afternoon, right? So then you go in, and if you want to figure out whatever the index for cost, you can select the state or location, right? Whether it's what division, and then it'll kick out some data here, some results on, okay, here's the locations, here's the indexes, right? Here's what we think those confidence levels are, right? And so in this case, right, here's an example. We had a project said it's $25.5 million. We think the estimate right now in 2022 is $25.5 million. It's 4-year duration project. It's going to take 4 years. We're going to start at 2024. That means our midpoint is in 2026. So they want to estimate to the midpoint. So we put those in, right? Current year, here's the cost. Here's the current year index, 1.21. The construction midpoint is 2026. And then so it pulls whatever that index would be for 2026. And then we just do a simple adjustment, right? And escalate it, so what that means then is that we should, in 2026 at midpoint, it should be take $32 million to do what in 2022 cost 25.5, right? So just an example, kind of how this looks. But being able to make quick adjustments and respond to those sorts of things without having to spend a ton of time developing it is kind of one of the benefits. So that's an application for that. Any questions before we move on? Yes.
So would you go back and look on the actual cost to refine your model down the road? Is that? You bet.
Yep. Yeah, and that's the thing too, is so wherever you're generating synthetic data, as you gather real data and actuals, you replace your synthetic data with actual data. And these are the kind of things where when you build a tool, like an estimating tool like this, it's a predictive model, it has to be maintained. You know, you got to maintain it. It's got to be updated. There has to be a regular process. Somebody manages it. You're going to manage either, or you're going to automate, you know, where it gets its data. If I can automate it, pulling cost data in and doing that stuff, that's even better. But if not, I have to have somebody who's at least in charge of going back through and saying, okay, quarterly, we're going to go through and we're going to, you know, we're going to update the database, you know, or hey, we're going to update the model. And because this is all algorithms, right? These are just programs. I can rerun this as many times as I need. You know, I'm just changing the data that's going in. So. All right. So next one here will show you some utility location. You know, this is this one actually comes from a provider here called 4M. They've been gracious enough to share some of their information with us. But when you look at utility location, right, it's a big issue. You know, number 2 unforeseen claims. This is number 2 cause of claims in construction. That was from a HKA report they do annually. That was from 2022. You know, and the market of utility location damage prevention is around $11 billion here nationally. So this is kind of a picture of who's involved in what, right? You know, you got the front end up here where you're talking about the SUE, you know, doing that ASCE 3822, the subsurface utility engineering investigation report. You know, got guys like, you know, 4N that's what's way up front. Then you got SUE and engineering folks like T2 or KCR Colliers, you know. And then we got location folks as well who are going to go in there and locate it, right? You know, privately, publicly. And then you got also on the back end, like screening and tracking as well. You know, so you got like USIC, you see those guys running around everywhere all the time with their little orange spray cans. You know, 811, everybody call 811 right before you go and have, you know, or Okie Dig or whoever it happens to be, right? Go out there and do your locates. Well, this is an application, a machine learning application to assist with that. You know, and when it comes to utility location, you know, there are a bunch of challenges out there, and this is a unique application where artificial intelligence has worked really well to be able to identify where probable locations of actual utilities are. So, you know, big challenges. We always got, you know, lots of different kinds of utility data out there, right? And it's not uniform. There's really no national standard. Even in states, there's lots of variation between municipalities, you know, between different owners, who keeps what kind of records. You know, are they digital files? Are they physical files? You know, the better ones they're using GIS. You know, so you've got GIS vector files for some. You know, for a lot of it, you don't. You know, you go into old, you know, little town here in Oklahoma somewhere. There's no GIS files for anything in their town. Shoot, they may not even have as-built for, you know, where they put sewer line and they replaced it. And if they do, maybe it's paper copy. You know, shoot, OU even still has a whole big down there facilities folks, facilities management still has a archive full of paper copies of everything down there, and it's not all digitized, you know. So that's kind of a challenge. Another one is, you know, large variety of unstructured data sets. So if you do find data, oftentimes it's not organized, or if it's organized, it's not all organized in a uniform manner. Quality variation is probably, I think, one of the biggest ones you see here as well. You know, and give an example of telecom companies. So most telecom companies do not track the depth of any of their lines. No depth data. They have no idea how deep anything is. And in a recent lawsuit, Comcast said that their lines are, the accuracy of the location of their lines is plus or minus 150 feet of the center line shown on the plans. Which is like, we don't know where it is, but it's in the area, we think, right? And it's a function of how they do business, though. I mean, because for them, it doesn't really matter to them if they know where it's at, right? They just need to know generally where those lines are running, and, you know, something goes out, they can go sort of find it, right? And so when you're looking at some of these things, you'll find the quality is a big issue, right? There's a lot of quality issues. Same thing with converting red lines to as-builts, right? You know, Yeah, you gotta, it depend, that also is a directly ties to the competence of the contractor and potentially the level of inspection on the project, you know, track where those things actually went, right? And, you know, that again is very, varies as well. Last one here is, you know, doing subsurface detection. It's a challenging task for computer vision. It can be done. It's called photogrammetry. And there's a whole bunch of applications for it, but even so, you know, it's one tool in the that's still very challenging to be able to identify, you know, looking at images to try to figure out where things are. So 4M, they developed, they're really the only one on the market that does this right now, and they've kind of become, their goal is to be like the Google Maps of subsurface utilities. So what they did is they built a AI model that uses an ensemble of deep learning methods or deep learning applications to be able to take and process all these different types of data and to land them all in vector files, essentially on a map. So you know, they're pulling vector data from GIS platforms and GIS servers. Going to be pulling pixel data from you know, images, videos. They can use process video images. They also can pull from news articles, historical pictures that are on archives, all sorts of stuff. And then also engineering data. So anything that's, you know, where they've got PDFs or DWG files or plans, as built, any geo PDF maps, and be able to pull those in, and then they have a fusion operation here as part of the pre-processing. So the vector data is then run through a conflation engine, and that conflation engine then takes and it bounces it against all of this other data here, right? What else do we know? What else do we see, right? And it's comparing it, and it's looking at, okay, how close or how far away is this from this other data? It uses a technique called data envelopment, which is I'm going to approach that data point from a whole bunch of different angles until I get to I can characterize, you know, generally where I think it should be, right? And if I can land all kind of in the same area from these different approaches, that increases my level of confidence that I know where this is. So they use pixel data, uses object detection, be able to figure out what objects are there, classify them, characterize them, geolocate them. And then, of course, digitization, taking engineered data and converting that into vector files that can then be run through this fusion engine and into like a searchable utility map. So, kind of how the processing works, right? So they use the base layer is a GIS map, right? So it uses GIS map files, existing geotagged utility data. And then it builds essentially layers upon that, right? Adds layers to that. They use for as-built plans. They have a artificial intelligence algorithm that assists with digitizing that. It's an AI digitization engine that converts those PDFs into and image files into geo-aligned vector layer files. So essentially taking anything that's a picture or an image or a PDF and turning that into a vector that's aligned, you know, properly. It'll extract utility location indicators, metadata, vector data, all the other stuff. Again, it conflates those. And then that vector data is then laid back over that GIS base model, right? So then you get these kind of layers of vector data, and we're able to look at, okay, how close is everything, right? Where does it look like things are? So pixel data is processed using AI computer vision, right? That helps increase the data quantity, fills in gaps, right? That's kind of what the pictures do. So where we've got plans and specifications and official documents, right? We're going to have missingness, right? So that's what the pixel data does. So this kind of shows you, you know, they take a PDF as built like this, and then it converts it into a GIS file, right? Vector file. And we fill in the gaps there with the picture. So there's all sorts of different sources that they use: aerial satellite photography, open source mapping images like Google Street View. It'll pull historical images. It'll extract out of news articles, you name it, right? videos. And then object detection is actually pretty slick. So they've got vertical and horizontal detection. So like for your vertical detection, right? It said, oh, here's something right here. And it pulls that out and says, oh, these are manholes, right? So the machine learning algorithm then knows that, okay, this shape, if I look at this, I've learned that that's what this looks like in a vertical, application. That's a manhole. So I'm going to call this manhole, and I'm going to geolocate that on my GS file, right? It can do the same thing with horizontal data. So like it noticed, hey, guess what? Oh, here's a fire hydrant. I know what fire hydrants look like. Boom, here's my fire hydrant. I'm gonna classify that. It's gonna have a name, a number. It's gonna be geolocated as well. So, and it pulls those out, even though these goofy like panoramic like Google images, like from street maps. And that AI algorithm essentially goes through and processes the data and lands it where it needs to be. And then of course they have folks who are doing quality control on this as well. But now the object detection stuff is really, this is actually, I think, even more interesting to me, is using these photogrammetric algorithms where they'll take and compare current imagery with historical imagery, historical satellite and aerial photography, and be able to look at highlighting any places where there's visual evidence of change, right? Where there could be buried utilities. So it'll look at things like, on this one here, and hey, here's a picture, and it identifies, hey, there's an excavator. Right? There's an excavator here. Here's some pipe that's laid out here, and this box is just saying, hey, the computer vision algorithm identified something here, and then it's going to try to characterize it. Here's another one, right? Hey, here's a pipe sticking out of the ground. Here's another pipe sticking out of the ground. And as it processes it, it's going to say, okay, well, if this pipe is aligned like this and this pipe's aligned like this, maybe that line goes through here, right? And it'll lay that down with a certain level of probability, and that gets layered on top of anything else we know, right? And those are again also geo aligned as well. So again, what you're doing is you're just adding additional layers of probability on top of it. So we build these heat maps, essentially saying, okay, well, here's where we think these are. Here's the confidence I have that this is within 1 foot or 2 feet or 10 feet or whatever. The last one they use is an application of engineering logic. So this is one where it detects things like, hey, this is an example. There's an unworkable slope here, right? You got horizontal and vertical imagery, and it goes, hey, guess what? This is an unworkable slope. So, even though the as-built shows that the telecom line goes through here, it probably doesn't. And then it's going to recommend where it thinks it might be. Right? Hey, maybe it goes around this way, right? And then it's going to compare that to any other evidence that they have as well. So it makes some of these recommendations. It's pretty slick, anyhow, there's a link in here. You can follow this tool. This is one you can click on and go through, and you can play around with it in there. We're at lunchtime right now, so I'm not going to go and show you what that looks like. But essentially, the way this works is you go in, you draw the boundaries around the area that you're interested in finding the utilities on, right? And then it'll tell you what's already there. And if you need it within a certain amount of days, they'll go through and they'll pull additional data and process additional data and show you what that is. Now, I don't think there's any data in Oklahoma right now, but they've mapped all of Texas and like bunch of other states. So they're trying to map all the states as well. But they can also find stuff in like heavily built up urban areas as well. They had a real interesting case that that I saw last year, where they showed on a brownfield site out in West Texas. They found two utility lines that nobody even knew were underground, and they found it because the computer vision algorithm had detected these linear features in the soil. And then they found historical photos of them being installed, of like people out there actually digging. Had another one where it was a utility line ran along a railroad, and it showed the utility line running along it, and they had pictures of the guys out there laying it, and you could see how it jogged around, right? They were out there actually putting it in. So being able to conflate that data and say, okay, well, it says it's here, but it's probably here, right? And so these are the kind of tools that are out there. This kind of the application for this is especially up front. You're looking at doing right-of-way acquisition. You're looking at doing utility relocation. I need to know what's out there, and if it'll pull up a list if they've mapped the area. Hey, here's all the utilities we think are here. here's who they are, here's their contact information, right? That gives me a hit list. And if I got a hit list, I can then go and start the process, right? Hey, I think this is here. Hey, I think this is here. What do you think, right? So, any questions here? I think we hungry? Yes, go ahead.
I guess like why so much variation on where utilities can be located, because you do have right of way, and I don't know about some of these utilities, but I know for electric utilities, if you get out of that right of way, you're subjecting yourself to some
Oh, you bet.
liability. So there's a lot of efforts made to make sure at least you get your utilities in the right of way corridor.
Yeah.
It's interesting that apparently there's a lot of utilities where that's not a concern.
Absolutely. Well, or it's just, or they're older ones, you know, or they're abandoned. That's the other one too. You'll find abandoned ones, or you'll find older ones where it's, you know, you got the, there's no record of it, you know, or the records are out there, but they're not correct, or they're just slightly off. Yep. So I asked to repeat the question. So the question, the comment was, it was that, you know, it's kind of a surprise, you know, to have to hear about as much variation in the location of utilities as compared to their as-built documents, especially, you know, considering, you know, like if you're dealing with an electrical utility, getting out of that easement, you're definitely getting yourself in a lot of trouble. So, but yeah, there's it's a real challenge. I mean, it can be a real challenge, especially you know, if I mean, I don't know. I'm sure y'all have had plenty of projects where you run into something you didn't expect it to be there, or you thought it was going to be somewhere else, you know, or you have one where, you know, you hit like had one where the contractor hit a medium pressure gas line. They thought it was like 2 or 3 feet over, and they were in there digging with a little mini X and just nailed it, you know, as opposed to using hand tools, you know, didn't pothole. But you know, it's a way to supplement that, and that's the other thing too. Is, you know, talk about potholing is if I've got a map like this, I can plot that thing out, and I can go hire someone to pothole those for me. You know, go out and find them right now. You know, before I have to do anything, figure out where those actually are, and if they're in my right of way and I got to deal with it, I got to go deal with it. And if they're not, hey, even better, right? So, any other questions or comments here before we break for lunch? Okay. Any idea on how long the lunch is going to be? Oh, okay. So we got a little time here before the food shows up. Okay. Well, I'll tell you what. If that's the case, if we're still waiting on that, I will. I'll give you a little. We'll go through show you the tool here, so you can kind of see what this looks like. So give me one hot second here. I'm going to end my slideshow. Oh shoot! What did I do that for? All right, so this is no, it's not convenient. Let's see. Oh, this stinking image thing. It just, here we go. Let's try this. Here we go. All right, so this is just an example here. So if it works kind of like just like you'd pull into Google Maps or something, right? So this is a demo project they got down here. So essentially you go in and you just trace out what you want around it, right? And so if I zoom in, you can see along this project, anywhere I got like a heat map, like this is all, you know, likely locations of underground utilities. And you know, I can go in here and look at you know, what's here. I can unlock, you know, different layers and stuff, looking at the utilities. Get data. Oh, let's see. I'm on a free one here, so. But anyways, what it does then is you'll be able to pull it up. See, it's not pulling that up. Let's see if that. No, I must have clicked too many times on this. for this to work for me. But anyways, what it does is it'll pull up a list of each of the owners for each of these layers and say, hey, here's telecom, here's this one, and then it replaces these with vector data. But if I'm looking at this just from a planning standpoint, all right, that gives me a good idea of where everything's going to be, right? In general. So like, I had another one here back in looking at Muleshoe, Texas, where I was talking about earlier. This was my first road project I was ever on. This was a little resurface project between Muleshoe and Sudan, Texas, home of the Fighting Hornets and Hornets. But even out here in rural Texas, you can see you've got likely some underground utilities. You got one looks like it crosses underneath the road as well, right? And wherever you got these density maps, you'll see different stuff. Like, and here's a spot right here, right? That's just a single spot. That might be a well or something, So yeah, here you go. Here's even more. But that's kind of the idea, though, is you've got it's kind of like Google Maps. You can go in, you can click on it, I can edit my project. I can see where everything's kind of laid out. Here's my different roads and stuff. If I wanted to go in and like add some more to it and say, oh well, I want to stretch it down, I can stretch it down or do any of that kind of stuff. So, all right.
Do you coordinate your work with the state utility permit systems?
I don't have an answer for that. This actually is not my system. So, but this is it's kind of like a service, that you get. You can have them come provide. So like over here, they haven't mapped Oklahoma yet. I don't even know if they have any clients up here in Oklahoma. But essentially they'll do is be able to show you essentially where everything's at, contact information, that sort of stuff. And wherever there's the ability to like tie into an existing system that they can tie into and pull data or feed data to, that's another thing that also works in there. Okay. Let's see. I was looking up here in Oklahoma. I thought, what would be cool is to look up what's right around here around the ODOT Center. But again, they don't have anything mapped up here. So, but if I was looking at where we're at, this would be I could look up here and say, oh, here we go. What's in this, right? And if you wanted data, you could get them to generate the data for you. But all right. Well, let's eat some food. We got food here. We're gonna take until about 12:30. Does that work good, or we want more than that?